Assalamualaikum everyone and welcome to our video. So this is our group project. We will be presenting about analysis of function in calculus 1. So let's get into the video. Okay, but before that, I will introduce our group. So that is myself. My name is Muhammad FARIZ bin ZAIMI, and that is Muhammad AIRISHAH ILHAM bin PUDIN, and then that is Muhammad SAFWAN bin SHAHROM, and AHMAD ALIF bin KAHAR. Okay, so what is analysis of function? The analysis of function is in calculus involve utilizing differentiation technique to study and understand the properties, critical point, and behavior of function, particularly polynomial and rational function. It encompasses the identification of critical point, determination of maxima and minima, inflection point, and solving optimization problem. Additionally, for rational function, this analysis will include identifying asymptote. This analytical process provides crucial insight into the function characteristic, play a fundamental role in calculus application across various disciplines such as physics, engineering, computer science, and a lot of other fields. Alright, so let's take a look at the first one, which is analysis of function 1, which we were involving a polynomial function. So consider function f of x is equal to minus 2 over 3 x cubed plus 3x squared. So that is 5 questions usually. So the first one, you will see the question asks for you to find the y-intercept and x-intercept of f of x, which is the function. The second one is find the critical point of f of x. The third one is find the interval where function is decreasing or increasing. Hence, determine the extremum point of f of x, if there any. The fourth one is find the interval where f of x is concave up or concave down. Hence, determine the inflection point of f of x, if any. The last one, you have to sketch the graph of f of x using the above information. So below that we have a step-by-step on how to solve the question.
For the question A, we need to find the s-intercept. First of all, we need to take the equation fx equal to negative 2 over 3x cubed plus 3x squared. And then we need to let fx equal to 0. After that, we need to factorize, which is x squared negative 2 over 3 x plus 3 equal to 0. And then first x we get x equal to 0 and x equal to 9 over 2. So x-intercept is 0, 0 and 9 over 2, 0. For the y-intercept, we need to take the equation back. Fx equal to negative 2 over 3x cubed plus 3x squared. And then we need to put the x, we need to put the 0 into x. So y-intercept is 0, 0. For the question B, we need to find the critical point. We take the equation fx equal negative 2 over 3x cubed plus 3x squared. And then we differentiate. After we differentiate, we get fx equal negative 2x squared plus 6x. And then we let the differentiated, and then we get negative 2x squared plus 6x equal to 0. After that, we need to factorize, and then we get x equal to 0, and another x is x equal to 3. So critical value is x equal to 0, 3. That one is for critical value, but the question want the critical point. So we need to put the critical value in, we need to put both critical value in equation back. So after we put, and then the last answer is critical point is 0, 0 and 3, 9.
Assalamualaikum and hi everyone. My name is Muhammad Safwan bin SHAHROM and I'm from class A4 CTCS 11028. Today I will present you question C, which is find the interval where function is decreasing or increasing. Hence, determine the extremum points of fx, if any. Given the critical value x equals to 0 and 3. First, we have to create a table which is interval, test value, sign of f inverse x, slope, and increasing or decreasing. For interval, we have a point which is 0 and 3. We put it in the interval. First column, which is negative infinity to 0, and second column 0 until 3, and the third column 3 until infinity. For the test value, we choose negative 1 for negative infinity to 0, and for 0, 3, we choose 1.5. For 3 to infinity, we choose 4. So for the sign of f inverse x, we put in the equation, we got negative, positive, and negative. For the slope, we got decreasing, and increasing and decreasing. For next question, which is question D, find the intervals where fx is concave up or concave down. Hence, determine the inflection point of fx, if any. Fx equals to negative 2 over 3x cubed plus 3x squared. And then we differentiate it, we got f prime x equals to negative 2x squared plus 6x. And then we differentiate it again, we got f prime x equals to negative 4x plus 6. And then let f prime x equals to 0. Negative 4x plus 6 equals to 0. Then negative 4x equals to negative 6. Then we got x equals to 3 over 2. For the inflection point, we got 3 over 2 and 9 over 2. And then next step, we have to do the table again. What we have here is interval, test value, sign of f prime prime x, and concavity. For interval, we put negative infinity and 3 over 2. And for the next column is 3 over 2 and until infinity. For test value, we choose 1 and 2. For sign of f prime prime x, we got plus and negative. For concavity, for sign plus concave up. For negative sign, concave down. Next question, which is question 8. Sketch the graph of fx using the above information. So we have here x-intercept equals to 0, 0, and y-intercept equals to 0, 0. So we have point at 0 and 0, and then we have to make a point or bullet at that. Then we have minimum point, which is 0, 0, 2, and then inflection point, which is 1.5 and 4.5. Then maximum point, 3 and 9, and then x-intercept, which is 4.5 and 0. Then you just sketch it using the point that given, and then you get that graph.
Assalamualaikum and hello, my name is ALIF. I'm going to explain about analysis of function 2 rational. So our function is 5x minus 10 over x minus 4. So first we need to find x-intercept and y-intercept. To find x-intercept, we need to equal the equation with 0. So I'm going to move the x minus 4 to the right, make it 0 times x minus 4. So still equal to 0. And then we move minus 10 to the right, so the sign change from negative to positive. And then I will bring the 5 to the right, make it 10 over 5. So the answer is 2. So x-intercept is 2. So now we move to y-intercept. So y-intercept, we have to make the function to f0. So I will replace I will replace 0 to all x we have in the function, and then we will get 5 over 2. So that's our y-intercept. So now we want to find vertical asymptote and horizontal asymptote. For vertical asymptote, I will take the denominator, which is x minus 4, and then find the x. As we can see, x is equal to 4. After move 4 to the right, so for find the infinity sign, we use 3.99 for 4 negative and 4.01 for 4 positive. So we get negative infinity for 4 negative and positive infinity for 4 positive. And then for horizontal asymptote, we use limit x approaching infinity to find horizontal asymptote. So the biggest x power for denominator is x power of 1. So all will divide by x power, so power of 1, and then we will get 5 over 1. So the answer for y is 5.
Right, for the question C, find the interval where function is decreasing or increasing. Let's take the original function, which is f of x is equal to 5x minus 10 over x minus 4. So to find the function where it is decreasing or increasing, you have to differentiate the function. So first we have to let u equal to 5x minus 10, and then differentiate it. We will get u prime equal to 5, and then we will let v equal to x minus 4, and we will get v prime equal to 1, and we will substitute all of this into the formula. So next is you have to simplify the equation, and then you will get minus 10 over x minus 4 in bracket square. After that, you have to let f prime of x equal to 0, and then you will take the denominator, which is x minus 4 in bracket square equal to 0, and you will get the answer of x equal to 4. The next thing, you have to create the table. So we have the interval on the top, we have the test value, and then we have the sign f prime of x, and then we have the slope. So the interval, you can take the value of x is equal to 4, and then make it as a center. After that, you take the value that is 3 as it is less than 4, and the other side is 5 as it is greater than 4, and then we will take the test value and substitute it into the prime of x, and then we will get both of these is negative, so it means the slope is decreasing.
Okay, next we need to find the concavity. So the first derivative is minus 10 over in the bracket x minus 4 power of 2. And then second derivative is 20 over bracket x minus 4 power of 3. And then I'm going to let the second derivative equal to 0. And then we got x equal to 4. So our test value for negative infinity to 4 is 3, and 4 to infinity is 5. After insert this inside the function, we got negative sign on negative infinity to 4 and positive sign to 4 to infinity. So concave down for negative infinity to 4, and concave up is for 4 to infinity. For this function, we don't have inflection point.
Alright, so this is how we sketch the graph of the function. So first one, we have the function, and then we have the asymptote, which is x equal to 4 and y equal to 5. And next thing, we have to point where the point of y-intercept and the point of x-intercept. Alright, for the conclusion is what we learned is that analysis of function focus on mastering analyze a function through calculus using first and second derivative. From first derivative, it enables us to understand and find the critical point, maximum point, and minimum point, along with the interval of increasing and decreasing of a function. Then second derivative allow us to find the interval of a function where it concave up or concave down. Additionally, for rational function, you can also find and understand where the vertical and horizontal asymptote through limit, which one of the fundamental in calculus, where you find the value of a function when limit of x approach certain value. Alright, so that is all from our group for this project. So I would like to thank you. Goodbye.